Today I'm going to show you how to build this, a 2-inch FPV drone for just $100. This is going to be the smallest build we've done so far, and I'm going to give a little warning, this involves some really precise soldering. But if you're up for the challenge, by the end of this video you should have a fully functioning 2-inch FPV drone. First up, let's take a look at the parts. For the frame, we're going for this Apex 2-inch frame kit. It looks a lot like a stubby, shrunken down 5-inch frame, and it kind of has its own charm to it. For the flight controller, we're going for this JHEMCU F411 all-in-one board. This is a neat little board because the Express LRS receiver is built right on the board, and it only costs about $33. The built-in ESCs are only rated for 12 amps, but that's plenty for the tiny motors we're going to be using. The motors are 1104 size, 7500 kV motors from Yasuda. The 8600 kV motors should work as well, but I haven't personally tried them yet. For the props, I tried a whole bunch of different 2-inch props, and surprisingly the ones that gave me the best flight times were these 5-bladed Cinewood props from GemFan. I think these motors are actually pretty torquey, which is why they work so well with 5-bladed props. For our video system, we're going for analog with the Zeus Nano VTX and CADX and camera. If you want to go digital with Voxnail or HD0, this is also a good candidate for their respective whoop boards. And finally, for the battery, I recommend a 2-cell 650 mAh LiPo. I've tried 450 and 550, but those had really short flight times. LiPos can be a little bit of a hit or miss on AliExpress, so if Amazon has these 2S LiPos in stock with Prime shipping, I would really recommend just getting it from Amazon. That's everything we need for the drone, but if you're brand new to the FPV drone hobby, you'll need some supporting equipment as well. For radio, we're going for the Radiomaster Pocket with Express LRS. For goggles, the classic Eachine EV800Ds are a good value. And for charger, the Hoda D6 is a good choice. All three of these aren't the cheapest options, but they're the best value for the money, and they can be used far down the road with tons of other FPV drones. But if you are on a really tight budget and you do want the absolute cheapest gear, here are some options. For the goggles, you can get VR009 goggles for just $50. Just don't expect the best signal from them. For charger, the tiny B6 Neo is a really good value as long as you have a USB-C phone charger to power it with. Just keep in mind that supporting gear like radio, goggles, and charger are buy-it-for-life kind of items. If you buy it right the first time, you'll never have to buy any more in the future. Soldering is going to be especially important on this build, so here's a quick look at my soldering setup. My iron of choice is the Pine Sol, but the TS101 will also do. I've also stockpiled an assortment of tips, and for this build, the superfine chisel tip TSC1 is going to do a lot of the fine soldering work. For solder, I use Kester 6337 leaded solder in 0.8mm diameter. You don't have to use this exact brand, but since I solder a lot, I decided it was worth to spend $30 on this big name brand roll. To clean my soldering tips, I use this brass sponge to get rid of the large pieces, and then I drop some liquid flux onto the hot soldering tip in order to make it shiny and remove any oxidation. To hold stuff while soldering, I like using these magnetic helping hands. Also really handy are these magnetic circuit board holders. Now let's get started with the build. The first step, and in my opinion the most fun part of any build, is to assemble the frame. It's always a good idea to do a full assembly of the frame so you know where every part is going to go. This frame kit doesn't come with any instructions, but it's simple enough that you can just look at the listing photos to see how it all fits together. One neat feature of this frame is that it has 3D printed soft mounted camera dampers. Those are the two red parts. This could make it a good option for the new DJI-04 Lite, which requires soft mounting for best performance. To prep the flight controller, attach the included UFL receiver antenna to the onboard Express LRS receiver. Then install the red rubber dampeners on the corners. The longer side of the dampeners should be on the same side as the USB port. Next, it's time to do a dry fit of the components onto the frame. This means screwing everything onto the frame, but not soldering or cutting any wires. This is important to make sure that everything is going to fit properly and to plan the wiring layout. Mounting the motors is pretty easy using the included M2 screws. Same thing with the CADX and camera, use the included screws to mount it to the red 3D prints. We're going to need to provide our own screws to mount the flight controller and video transmitter. I highly recommend picking up an M2 screw assortment kit. It'll be handy in this build and any more builds or small projects in the future. I use 10mm long screws and nuts to mount the side mounting holes on the flight controller. Then I used longer 16mm long screws to mount the video transmitter and the flight controller together in a stack. The video transmitter doesn't come with any standoffs or gummies to space it up, so I took some spare black silicone gummies, cut them to length, and then used those as spacers. Right here you can see the overall layout of our build with the VTX mounted on top of the flight controller. The stars also aligned in this build as the USB port on the bottom is perfectly accessible through the bottom of the frame. Here is the completed dry fit. Now that we know how everything will mount, we can start working on the wiring. Our first task is to wire up the main battery cable to the flight controller. It comes with a white JST plug that's really only intended for 1S builds. Since this is a 2S build, we're going to have to provide our own XT30 connector and 20 gauge silicone wire. Start by soldering wires to the connector, making sure the red wire goes to the plus symbol on the connector. I cut my wires to be about 50 millimeters long. Next, it's time to solder the battery cable to the flight controller. I'm using the stock conical tip that comes with the pine cell iron. Double check to make sure that the polarity is correct. It won't matter if you solder the wires coming out the top or the bottom of the board, there's enough space in the frame either way. You can see it better here, mounted to the frame. Next, we have to solder the motor wires to the flight controller. Each motor has 3 wires, and it doesn't matter which order you solder them on. I needed to trim the motor wires just a bit to get them to the right length. The pads on the flight controller are very, very close together, and you don't want to accidentally short any of the 2 pads with solder. Switch to the tiny C1 chisel tip on your iron, which should help prevent accidental shorts. Soldering the motor wires to these tiny pads requires a very delicate and precise touch. Steady hands are a must. I also bumped up the temperature on my iron to 340 degrees Celsius since the tiny chisel tip loses heat pretty fast. To solder the wire to the pad, I tinned the wire with solder, then tinned the pad with solder, and then I could bring the 2 together and melt them together with the soldering iron. Good quality tweezers are also important because it's impossible to hold these tiny wires with bare fingers. I stole these nice eyelash tweezers from my girlfriend. Please don't tell her. Also, I don't want to add too much pressure, but since this flight controller is an all-in-one board, if one component fries, then the entire board is a loss. So if 2 of the motor pads are accidentally shorted together while the motor tries to spin up, there's a good chance the MOSFETs will fry, resulting in a total loss. That's why it's important to take things slowly and carefully. If you're not confident in your fine soldering skills, I'd recommend picking up some soldering practice kits, especially ones that focus on small surface mount components. These are really cheap and ideal to learn and practice on. If you mess up, it's no big deal. If you do end up shorting 2 of the motor pads together, don't panic, it's an easy fix. Start by desoldering any motor wires to start fresh. Use flux on the tip of your iron to make the tip nice and shiny, and hopefully you can melt and absorb any extra solder that's causing the short. A small amount of flux placed directly on the short can also help melt it away. I'd recommend some good quality Kester no clean flux. I have some generic AliExpress flux here, which doesn't really work as well. Only once the board is clean and there's no excess solder or shorts should you try again to solder on the motor wires. And as always, there's no need to rush. Take your time and do it right. What you're watching here is the full process of soldering one motor. It's taking a while even though the footage is sped up at 2x speed. I wanted to show exactly how I did it since this is such a crucial and tricky part of the build. And there it is, that's one motor soldered on. Repeat this for all 4 motors. Overall, I think it took me a solid hour to do all of the motors. This next step is optional. I noticed that there aren't any large capacitors on this board to soak up any voltage spikes. I chose to solder a 10 microfarad capacitor across these 2 pads, bat and ground. The drone should still work without this capacitor, this is just out of an abundance of caution. Next, it's time to solder the Cadex Ant camera to the flight controller. The camera comes with cables that we can cut to length and solder. There are 3 connections that we need to make, 5 volts, ground, and cam. I'll put the full wiring diagram in the video description below. The video transmitter requires 4 connections, 5 volts ground, TX2, and VTX. Start by tinning the pads we need on the flight controller. Then, solder the wires included with the VTX onto those pads. Finally, we can solder the other end of the wires to the pads on the VTX. Also, don't forget to plug in the included antenna into the VTX. If you forget the antenna, there's a chance the VTX can fry when it's powered up. That's it for all the wiring and soldering. Stack the VTX on top of the flight controller. If you have the spacer set up properly, the VTX shouldn't touch the flight controller, it should just be spaced above it. Now it's time to button the drone up by screwing everything back together. The frame comes with a little 3D printed antenna mount that goes at the back. And there it is, the nearly complete drone. But don't put the props on just yet, we need to set up the software first. Alright, it's time for the Betaflight setup. We have the drone here, we have a micro USB cable, but first we have to plug in a cooling fan to cool the drone because we're going to be powering it on and it's going to be overheating. So I have a little USB powered fan that I'm going to turn on. Get some nice air coming out of that. So first let's plug in the USB cable. Hopefully it'll be recognized by Betaflight. Okay, and we can move it around and we can see the drone moves around, so that's perfectly fine. But the first thing we want to do is actually we want to disconnect from Betaflight now, and we're going to go to ESC configurator. So the reason we're going to ESC configurator is because these motors are going to have a tough time spinning up because they are very coggy. The magnets are very powerful, so we need to give it some startup boost. So let's connect to the flight controller using ESC configurator. Remember to always disconnect from Betaflight first before you do that. And now we can go ahead and read the settings of the ESC, and it's going to read all of them, and they're running BlueJay. So that's pretty surprising. This is my first flight controller that actually comes with BlueJay pre-installed. All of my stacks before usually just come with BLHES, so it's nice that they come with BlueJay. And the thing we want to change here, the minimum startup power and the maximum startup power. So right now the power is going to be too low, so the motors aren't going to spin by default when we arm it. So let's go ahead and boost this maximum from 1100 to 1200, and minimum startup power will go from 1025 to 1075, I think. So that'll give the motors a little bit of boost at the start in order to get them spinning. We're gonna go ahead and hit right settings. All right, all 4 ESCs have updated, so that should be good, and they're all already on BlueJay, which is great. So we're gonna disconnect from ESC configurator. Next, we're going to go back into Betaflight, and we're going to do the rest of our setup in Betaflight. So let's go ahead and connect back to it. All right, now our flight controller firmware version is actually already 4.5.0, which is pretty recent and updated. So I'm actually not going to update the firmware on the flight controller because that's new enough. But we do have to bind it to our transmitter. So actually taking a look at the LED, we have a green flashing LED on the flight controller. That's the Express LRS LED, and it's flashing green rapidly, which means it's in Wi-Fi mode. So we can go ahead and connect to the receiver's Wi-Fi network. The Wi-Fi name is Express LRS, and the password is going to be Express LRS, all in lowercase, I believe. All right, I've connected to the receiver. It'll open up Microsoft for some reason, but then it'll go to 10.0.0.1. So that's the web address we need for the Express LRS receiver. So go to 10.0.0.1, and it should pop up right here. And here we can enter in our binding phrase, and my binding phrase is pineapple. That's the one I always use. My Radiomaster Pocket, I already loaded the binding phrase pineapple on it when I first set it up, and I just never have to set it up ever again. For all my future drones, I just have to enter in the binding phrase. You should always use your own unique word. Pineapple is going to be my word, so please don't also use pineapple. So we can head back over to Betaflight. I'm going to go ahead and turn on my radio now.
Welcome to HTA.
In order to get the receiver to actually connect to the transmitter, we have to do a power cycle. So I'm going to unplug the drone, and I'm going to plug it back in. Okay. Oh, and we get good signal on the radio. So let's go to the receiver tab and jiggle the sticks. So in the receiver tab, it should be by default set to CRSF, which is Crossfire, which is the protocol that Express LRS uses. So if I jiggle the sticks, yes, I get a good proper signal. That's good to see. We can leave that alone, and let's go ahead and set up our modes. The modes I'm going to use, ARM, of course, is always going to be on aux1. And we generally want the higher range. That's what I do. So I'm going to do the higher range as armed. And then next is our stable mode, angled mode. So that's going to be aux2 for me. I have that set up on this switch over here. So I'm going to also set that to that. Should I do anything else? Should I do like a beeper or something, just in case I crash it? Let's go over back to my receiver tab. What do I have set up to aux3? Which is aux3? Oh, I have aux3 set to this switch for turtle mode, but I'll actually use that for beeper, I think. So let's go back over here. We have aux1 on ARM, we have aux2 on angle mode, that's good, and then let's turn on beeper on aux3 actually. Okay, so that's all the modes we need. Let's go ahead and set up the VTX in the ports tab anyways while we're here. So we can go to ports, and UART2 is going to be our VTX, which is IRC tramp. So let's do that, and let's do save and reboot. Connect. Let's go back to our video transmitter. Device ready is true. Okay, so it does read it. And now we have to enter in our VTX table. In this case, I can't actually find the file for it. So I'm actually going to go to Oscar Liang's website, And they should have a VTX table here, Betaflight VTX table. We don't need to copy the first part, we need to copy this last part over here. Okay, let me copy and paste it into Notepad. So this is what it should look like more. So this is our VTX table. You can go ahead and copy these like this. Then I'm gonna go into the CLI and then I'll copy and paste it here. Save, disconnect, reconnect. Let's go back to the video transmitter. It's ready. And now I'll set my band and channel. I fly in band A, channel 6. And for now, just for setup, I'm gonna set it to 25 milliwatts. And then I'm gonna hit save. Now let's turn on my little monitor here. And oop, I get a video feed. Great. I'm gonna wait to set up the OSD elements until after I've done the motor. So now let's go ahead and set up the motors, I think. The first thing I'm going to do is I'm going to disconnect the drone. We're going to need to power it up with a battery. So I have a 2S550 battery here. So remember, USB cable is unplugged, and I'm going to plug this in. And then I'm going to check the motor startup power right now just by arming it, make sure there's no props on, make sure the accelerometer is calibrated. And I'm just going to arm it just to see if the motors spin. Hopefully they do.
Armed. Disarmed.
Okay, they spin, but they seem a little low. The idle seems a little bit low. So let's go ahead and now we can plug in our USB back in. Let's go to the motors tab, and I'm going to bump the idle speed from 5% to 10%, I think. Okay, and now we can't arm it right now because we're plugged in. So let's go ahead and just go through the wizard. So let's go the reorder motors wizard. Props are off, I understand. Let's start. Pick the spinning motor, which in the case is back right, forward right, back left, forward left. Save that. Go back to motors, motor direction wizard. I understand, we'll do it individually. So let's spin number 1, which is the back right. And that's spinning the wrong way. We want prop spinning this way in. We're gonna match the little diagram on Betaflight, so I'm gonna hit reverse there. And that's correct. Motor 2, that's wrong, so hit reverse on that. And there we go, it's fine. Motor 3, which is this, that one's spinning correctly, that's fine. Motor 4, that's fine. Cool, so that is our motor directions set up. And now let's go ahead and we're free to set up the OSD. So let me go ahead and set up the OSD to how I like it. So let's move voltage and current. Amps that voltage there. What else do I want? I want timer on and fly minute down here. All right, and with that, that's the OSD setup. So I can hit save, and that should be the end of the Betaflight setup. So now it's just time to attach the props, get the battery attached, and we should be able to go fly. Oh, actually one last thing. Video transmitter. So we don't want to fly at 25, so I'm going to set it to 200, and we are going to do low power disarm. Saving, saved. Cool, we're ready to go. It's time to install the props. This drone is small enough that you can just press them on, no need to use prop screws. And make sure that they're facing the right directions. These are 2-bladed props, and I found that these didn't have very good flight times, which is why I experimented a bit to find the 5-bladed props that work the best. Before we take it out for a flight, we need to go over the screws again with thread lock. Any screw that is screwed into metal, like the motor screws or the stack mounting screws, they need to be thread locked so that they don't vibrate out. If a screw goes into plastic, like the plastic frame standoffs, then you don't need to thread lock those. Use blue removable thread lock, not the red permanent stuff. When testing your drone for the first time, it's always best to go outside in an open, grassy area. If you test it inside, you risk damaging walls and other stuff inside. Learning to fly line of sight, and not just through FPV goggles, is also a nice skill to have, but not mandatory. To measure flight time, I do an indoor hover test down to 3.5 volts per cell. The 2-bladed props I initially used got me pretty bad results of about 3 minutes, but then I switched to the 5-bladed props, and that made a huge difference, 7 minutes of flight time. I'd say that's pretty impressive for a 2-inch drone. And now let's take it on a flight. This flight you're seeing now was done with a non-optimal setup, the 2-bladed props and the smaller batteries. It still flies great, but the flight times just aren't as good as with the 5-bladed props. The video quality from the Caddx Ant camera is surprisingly good. It does have a little bit of barrel distortion compared to the bigger cameras like the Ratel 2, but it's totally acceptable and it still has a nice wide field of view. Also, right now I have the VTX set to just 200 milliwatts. I later changed this to the full 350 milliwatts and got better results. The signal is pretty good and I'm perfectly happy with the Zeus Nano VTX. I will say that the very first upgrade I'll probably make though is to switch out the stock linear antenna with a small RHCP antenna, like a Rush Cherry. This is a quick $5 upgrade and it usually results in a lot more consistent signal quality. I think this is mostly because it helps filter out small random Wi-Fi signals from the neighborhood, since most of those signals are linear like the stock linear antenna. Anyways, let's go over some of the advantages and disadvantages to the small 2-inch FPV drone. One of the biggest advantages is that it's quiet and non-threatening. Nobody really minds when you zip this around nearby, it just sounds like a little toy plane. It has a really harmless presence in the air as opposed to something like a 5-inch drone that sounds like a dangerous power tool buzzing around. However, the small size also makes it really susceptible to wind. A small 5 mph breeze may feel good for us as people, but it's definitely noticeable in the air for this tiny drone. Bump that up to a 10 mph breeze and all of a sudden the drone is really struggling to stay on track. A better PID tune could definitely help with this, so if you do build this drone and try out some different tunes, please let me know the results in the comments. Right now I'm using the stock PID tune, which works alright, but there's definitely some room for improvement. Anyways, hopefully now you know exactly how to build a 2-inch FPV drone for $100. Links to all the parts will be in the video description below. Thanks for watching, and I'd really appreciate it if you could subscribe to my YouTube channel.